So we're looking at number 78, and it's asking us what would happen to delta G. Notice this is not standard, and so delta G depends on Q, what the products over reactants are at a certain conditions. So we know that if Q is less than K, then it has less products than it should have at equilibrium, because Q is products or reactants. So it has to go more forward to reach equilibrium. And if Q is greater than K, then it has more products than it should have at equilibrium. It needs to go reverse to reach equilibrium. So if this is relating delta G with Q, it's the delta G equals delta G standard plus RT times natural log Q. So in each of these reactions, you have to look where hydrogen is. Hydrogen is a reactant in the first reaction, and so it's saying what's happening when partial pressure of hydrogen increases. So if H2 is going up, that means the reaction's going more reverse to make more H2. So obviously Q, if it's going reverse, is going down. Okay, Q is products over reactants, and we are increasing a reactant, so our denominator is going up, so Q must be decreasing. And if we look at this equation, if Q is decreasing, right, this whole sum value, if this number is getting smaller, then delta G is getting smaller. So it depends on where hydrogen is in the reaction. So we see in the next reaction, hydrogen's a product. So if we are increasing the partial pressure of the hydrogen, that means the reaction is going more forward, and we understand that Q is increasing because we are increasing the products, which is on the top of the fraction, so the Q is going up. And so if the Q goes up in this equation, the delta G must be increasing. So it's just making a relationship where hydrogen is in the reaction with Q and then to delta J. And for the last one, the hydrogen again is a reactant, so it should act as what happened with letter A. As we increase hydrogen, which is a reactant, it's going more reverse to do that. And so we understand Q is going down, and that would make your delta G to also decrease. And what that means now, we know that the reaction is going more reverse. I think if we think of this as like a Le Chatelier's problem too, where we increase either a reactant or product, you have an idea of what direction it will shift. So if you look again at the first one, if we're adding a product, hydrogen's a reactant here. If we're increasing the concentration of a reactant, then that means it needs to shift forward to compensate for that. And so that would make the forward direction more spontaneous. And so delta G is more likely to be negative or more negative. So delta G would be decreasing. And in the second one, we're increasing a product. So if you increase a product, we know the reaction has to shift reverse to reach equilibrium. And delta G always talks about, even though it's a reversible reaction, it always talks about the forward direction. So if we're increasing a product and it's going to shift reverse, that makes the forward reaction less likely to be spontaneous. And so the delta G would be more positive or increase, less likely to be spontaneous in that direction.